Okay, first thing I want to do today is talk a little bit about working with files and directories. For the most part, you won't need this. You'll notice you can find files, you can compare contents of files, you can open, you can create new types of files. So there's there's lots of ways to save and manipulate files and directories, but you can also do it from the command line. So there's a few things. It works a lot like DOS or Unix. Take your pick if you've ever worked with those things. So we can do a print working directory, tells us where we're at. We can cd space, we can go up one directory. Dot dot is to go up one directory, pwd again. We've gone up one directory. We can go back to Matlab, cd. I think lowercase will work. I'm going to give that a try. List all files, ls for list. So you can you can do other things like you can move files, you can copy them, make directories, remove you can do all the file manipulation stuff that you're used to. Most of you will probably prefer just to use the GUI, the Microsoft GUI. So this is about all I'm going to say about this. There's a reference in your book, page 55, about all the things you could do on the command line. But like I said, most of you you'll just go to the operating system. Let's get desktop. You know, you'll just manipulate from here. You'll move and copy and stuff like that using Windows. So these command line things are not that useful. So I've just showed you a couple, at least to let you know they're there. When you start working on scripts, really complex scripts in your third, fourth year graduate school or something like that, when you start working with that stuff, you might need this. But for the most part, if you're doing onesie twosie like the problems we're doing now, you won't need these commands. Okay. You can also find them in the help system, and it gives you a bunch of, okay, wake up help system. There we go. PW. Okay. And it doesn't CD, change directory. So a lot of times the help system will have C alsos. So it's kind of like the internet. You just keep clicking to find, and sometimes you can find what you're looking for. FTP, PWD, okay. It's giving me a circular thing. And of course, you can go up to this help system to look up things. And this help system is kind of hosed. It doesn't look like the help that it's supposed to. So when that happens, you can always go to the MathWorks website. Yeah, hey, Googling works.
Instead of math works, Google works.
Yeah, really. Good. You're actually quite right. Doing a Google search on what you're trying to do in Matlab or any other language for that matter, they have whole bunches of things out there. So, identify the current folder. So it CD dir lists the folder. LS and dir work the same way. Let's see, file operations, working with files. Oh, anyway, here's a whole big list in the help system. So most of the time you'll use Windows. At least in this class, you'll use Windows, but I wanted to let you know it's there so that when you move on, you're doing a graduate work and using Matlab, you're writing a really hairy script and it's importing all sorts of files and you're working with it. that you can program this. Okay, on to chapter 3. We've already talked about matrices a lot. MATLAB is very much matrix-oriented language. So I'm creating a so far I've been talking about square matrices. This time I'm going to something that's not so square. And when you add matrices, let's go B equals, I'll go 10, 11, 12, 13, 14, 15.
Wait, can't you just do like 10, colon, 12, semicolon, 13?
You know, I could have probably. Why is, or, there we go. So I'm adding two matrices. Basically, it's element by element. Row 1, column 1 is added to row 1, column 1 of B, and the answer is 11. Row 1, column 2 of A is added to row 1, column 2 of B. 2 plus 11 is 13, and so forth. That's how we add matrices. C equals A plus B. You're assigning the results of A plus B. You're assigning it to C with this statement. You can't. It doesn't assign the other way around. You can't do A plus B equals C. You can't flip it. But now I'm defining a new matrix, which is the sum of these two. And what were you saying about D? Let's see. Well, let's do this. Well, I'm going to negate. D is going to be the negative of B. Let's do that. And then let's go D plus C. If I do A, then D plus C should equal A. There you go. Multiplying matrices. So we have A is 1, 2, 3, 4, 5, 6. We'll make X equals, will this work? If I multiply A times X. You studied linear algebra, right? In high school? Right, right. They usually cover matrix operations in high school, but we tend to forget. You will see it again in your educational plan. Okay. Martin's saying this won't work. How many others think this? How many think this will work?
Now, it's not, do you have to put a dot after the A? Or is that just if A is, or is that if A is a,
Well, we'll get to dots in a minute. Let's see about this. That's correct. That is correct. Okay. Won't work. Matrix. This is a very common matrix problem. Now, if I want to add another element to X, there, I'm going to set a third element of X to something. As I said, 7, 8. Let's make the third element 9.
So the amount of rows is supposed to equal the amount of columns you're multiplying by?
Right, right. Okay, so now I can multiply A times X.
And it's different if you're, what kind of different multiplication do we have? You have,
Let's see. Here's another trick. Oh, well, let's do something a little different too. So X of, well, I better do a Y. Y of row 1, all columns. If I put a colon there, that means just fill up all the columns. And a lot of times we want to, um, if I'm creating a Y as a 2 by 3 matrix, a lot of times what we want to do is we want to start out with all zeros. We want to fill up the matrix with zeros and then change it like so. So I'm going to do Y1, let's see, first column, first row, all the columns. This won't work because X is a column vector. Oh, it did work. It went and automatically. You're right. So this is a gotcha. This is something to watch out for in Matlab. It does something we didn't expect. It just said X is a column vector, but this guy made a mistake. We're going to make a column. We're going to make Y be a row vector, but it's going to equal the elements of X, 7, 8, 9.
but how does that make any sense? Like, what do you mean y? Is that y times 1 through?
Y of, the parentheses, they're giving you the indices. So this is Y of the first row, comma, colon means all columns. Y of the first row, all the columns equals X. And it says, well, X is a column vector, but I think what you really want is to transpose X and set it equal to Y.
So just gives you the x, the y column into x, whatever. Yeah, switches them.
Right, right. Okay. So actually, let's see. Most of the time, if I want a 2 by 3 matrix, which I'm trying to get to, most of the time, what you want to do is um, fill it up with zeros first. It's computationally more efficient. So, y equals zeros of how many rows, how many columns. If I just put one number, I'm going to have a square matrix. So let's just do 3. There. It just makes a square matrix of zeros. So 3 will not give, if I just put one number, it won't just give you a vector. It assumes you want a square matrix. So that's another little nuance of this stuff.
What's the command for matrix in this formula? The zeros or?
It's just going to make a matrix of all zeros with the dimensions you specify. This is, well, if you just put one number, it's going to make a square matrix. If you put two numbers, the first number is the number of rows, second number is the number of columns. Boom. There we go. And then now we can start setting, well, I can just go back to the last command. I can just go up a little bit. There. We can start setting values. Second row, comma, all columns. So the parentheses is of. Y of, you specify the indices. Well, you can specify second row, first column. And let's go make.
The zeros that you have there into different numbers.
That is correct. That is correct. So the first time, I just made a blank matrix, essentially. I just made a blank one. The first time, I just did put the first row in this matrix. It overwrote the zeros. This time, I'm going to overwrite just one element.
Okay, so the colon on the Y1 colon, you're saying Y row 1 and then fill the rest of the column. So that makes it all of row 1 equals
That's correct.
X. Okay.
That's correct. There's another use of the colons, y of row 2, 2 colon 3. So,
Row 2 and 2, 3, which are the last two zeros.
yeah, last two. So we'll make those equal to 21, 22, 23. There we go.
Wait. Why'd you have to put 2 comma 2?
Um,
2 comma from 2 to 3, from row 2 to 3. Okay.
Row 2 from column 2 to 3.
correct. Row 2 from column 2 to 3. So this is a way you can load up submatrices. You only want to write data into certain parts of your matrix.
That's kind of what we did on the home one.
Right, right.
We had to put to like chapter 3 or something.
Yes.
Or did we create a vector?
So this is a way to, so that's a little bit of, so this gives you some hint of what's going on. There's also identity matrix, I, E, Y. Identity matrix, they usually use capital I, the capital letter I. This, I guess MATLAB's trying to be cute, so they use EYE for the identity. Okay. Z, matrix Z, or A, B, C, D, E, F, matrix F equals EYE of, you just give it, yeah, let's see it. There it is. One's down the diagonal of a matrix.
Yes, it's like a matrix 5 by 5 with 1 diagonal.
You'll notice if it's not square, it just takes the upper, it takes the left portion of the matrix and writes the ones into the left portion, and then whatever extra columns it has, it ignores the rest. The same thing would happen if you have extra rows. There we go. So it'll write your identity matrix as good as it can, and then it'll fill up the rest with zeros. We've already seen zeros. You've seen zeros in action.
Wait, Michael's got a good question. If you do like I times 3, would it, you have 3 on the diagonal?
Or you put a number other than 1 on a diagonal.
Booyah! Yes. If you want a number other than 1, a scalar times a matrix is just multiplying all the elements of the matrix. Let's go back to A. Let's see A. Let's do A times 2. Now, when you multiply scalar times a matrix, you're just multiplying all the elements. Obviously, a scalar is a 1 by 1 matrix. A is 2 by 3, so the dimensions don't match. But there's an exception. This is an exception. You multiply a scalar times a matrix, you're just multiplying all the elements of the matrix by that number. You'll notice before I used a negation. Negation works. It's like multiplying -1 times all the elements of a matrix. So that's scalars times matrices. The dot thing. Let's go. Let's go see what A is again, and let's go see what B is. We can do A times B transpose, and we get that. The apostrophe, you mean? That says transpose B. Let's see what it looks like. So here's B up here. We're flipping rows and columns. Right, flipping rows and columns. That's what the transpose does. Now, we can do, here's where the dot comes in. A dot multiply B. It will not give us the same answer. It won't give us the same answer as A times B transpose. It just takes all the elements, the one by one. Oops.
Well, you need to transpose B if you're going to multiply times
Oops,
A.
what did I do?
You didn't have the dot, the period.
Well, now I do.
Yeah, no, put the transpose
Yeah, there it is.
B. There you go.
I,
Oh, wait, no.
for some reason, oh, I know what I
Oh,
did.
you didn't have the dot up there. Yeah.
I did, I had the prompt sitting around that in a weird way that I forgot about. Okay, so A dot star B is not the same as A times B transpose. You can't do A times B at all. You can do A transpose times B, and you get a 3 by 3.
Also with multiplying matrices.
And the dot star up here, it's different than either one. Here's A dot star B. It's different than A times B transpose, and it's different than A transpose times B. And if we do both of them transpose and try to multiply, we'll get another error. Dimensions don't match. Probably the most common Matlab mistake. Okay. I'm creating an equation. Oops, I got to do D equals A times. If I divide D by A, if you multiply A to the negative 1 power, A inverse times D equals A inverse times A, which is identity matrix, times B transpose, I ought to get B transpose if I divide through by A. But I can't do it like this, D divided by A. If you're multiplying from the left, you've got to divide from the left. This will not work.
So it'd be A into D.
Perfect.
Boom.
Perfect. This will work. If your multiplication is not commutative in matrices. So if you're multiplying from the left, you've got to divide from the left. Just here's a rule. Somebody just said you're so lost. The rule is, if you're multiplying from the left, you've got to divide from the left. And what was? Yeah, I'm concerned about that. Okay. Let's take a look at everything. A, B transpose, A times B transpose gives you that. So if I do A into, oh, let's go, now let's double check that. D, yeah, it does equal D.
They should equal B transpose.
Yes.
All right, get the answer, then transpose the answer.
All that's going to do is flip it around. The numbers don't match up.
Let's just try it.
Um,
Now set that as an answer, and then transpose that answer. Transpose that answer. Maybe it might do
okay. You know, I'm at a little bit of a loss why this is failing. And I should get B prime. Here's B prime, 10, 11, 12. So, in fact, I'm getting a 3 by 3 matrix. I'm thinking, well, the answer is coming out 3 by 3. Now, what I'm thinking is, if we think of this in terms of simultaneous equations, we have 2 equations and 3 unknowns. So MATLAB kind of goes haywire when we try that. We've got to have 3 equations and 3 unknowns. So I think the matrix division is going to go a little bit haywire, do something we don't expect, mostly because the answer is ambiguous. It'll do something we don't expect if we don't have square matrices. If we have matrices other than square matrices, it'll do something we don't expect. So let's try this. Let's see, 7, 8, 9, 11, 12, 13. So I can multiply x times a, or a times x. Let's do b equals a times x. I can, oops. So if I take, so a times x equals b now. If I divide through by a into b, it should give me x, and I'll guarantee it won't. I'll show you why in just a second. Singular. This is what happens. Determinant of a, if the determinant is 0, which it's within a gnat's eyelash is 0, this is numerical rounding errors, then if its determinant is 0, then you can't get a solution. So what we got to do is make a matrix that is a non-zero determinant. Basically, when you get a 0 determinant, it means if we add or subtract, it's simultaneous equations. And one of these equations is the addition or subtraction or some fudging of the equation above it. So 7, 8, 9 somehow depends on, if you do some multiplication times 4, 5, 6 and add it to some multiplication of 1, 2, 3, you'll get 7, 8, 9. And I forget how that would work out. Let's see. Anyway, I'd have to figure that. I'd have to spend some time figuring out how they're dependent on each other. But what we can do to fix that, a of 3 comma 3, instead of being 9, let's make it 10. And make a non-determinant, det of a. Now we have a nice number. Now when we create our a times x, x is there we go. So now we can divide both sides through by a into b should give us x back. There we go. Yay! Now it works. Square matrices, non-zero determinant. Square matrices, non-zero determinant. Okay. Now, b equals a times x. Let's go b equals x times a. Now we're multiplying from the right. If we, okay, b equals x transpose times a. There we go. That'll give us something. Now if we do b divided by a, now we've got it. We're multiplying from the right. We got to divide from the right. Multiplying from the left, you got to divide from the left. And we get x transpose back. There we go. Okay. So some of the trickiness about matrix multiplication and manipulation. You found out about eyes. You found out about how to enter ranges of values, how to manipulate elements in the matrix. Okay, I'm going to stop here. We'll do relational operators we'll do relational operators on Monday. Exam will be on Friday, a week from today, just before spring break. Right. Right. And I'm going to work on getting Pertl computers to so that we might take the exam in Pertl so everybody has access to a computer.